Module 5.1, Getting Ready for a Pool Party, a Develop Understanding task. So the idea here is that we're just starting to get some ideas going here. So let's take a look at our story to get us going. Sylvia has a small pool full of water that needs to be emptied and cleaned, then refilled for a pool party. During the process of getting the pool ready, Sylvia did all of the following activities, each during a different time interval. So we've got these 6 activities, right? Removed water with a single bucket, drained water with a hose, her and 2 friends removed with 3 buckets, filled the pool with a hose, cleaned the empty pool, took a break. So first thing it wants us to do is sketch a possible graph showing the height of the water level in the pool over time. Be sure to include all of the activities Sylvia did to prepare the pool for the party. Remember that only one activity happened at a time. Think carefully about how each section of your graph will look, labeling where each activity occurs. So first of all, we're making a graph, right? So we got a graph here. Now it wants the height of the water over time. So we've got our height here, our time down here. Now, do we know any specific numbers? No, but that's all right. And it talked about each of these 6 items over a specific time interval, but it doesn't tell us what order they do it. But we've got a general idea of what's going to happen, right? We start with the pool full, we drain the water, clean it out, fill it back up, right? So thinking about that height, that's kind of a really basic graph of what it's going to look like, some sort of shape like that. Okay, so we can probably figure out which one of these would happen when. And if we're thinking about this, we've got 1 interval, 2 intervals, 3, 4, 5, 6. So 6 intervals of time here. So, thinking through this, drained with a hose. See, I think that would be the first thing that would happen. Because maybe we were able to drain some of it with a hose, but then we weren't able to do any more. So then we had to resort to the buckets. And maybe she started out with a single bucket, and then her friends came to help out, so they did it with 3 buckets. Then maybe they cleaned the pool or took a break. This took a break could kind of happen through any one of these, right? So maybe after, I'd say maybe after the buckets they took a break, then they cleaned the pool, then they filled it up with the hose. Okay, we know this one's going to be the last one. So we've got interval 1, 2, 3, 4, 5, and 6. So we start up here, our height. Okay. Now it says we drained water with a hose. So it's going to be going down, right? So let's say it goes down like this. Oops, it's a little curved, isn't it? And now the hose doesn't work anymore. Okay. And we've got to remember when we're drawing our graph, we've got to think, is it continuous or is it discrete? Well, this first part is continuous, right? Draining with the hose, it's constantly coming out. Whereas with the buckets are going to be discrete. So let's say now we are removing it with a bucket. So she pulls a bucket load out each time. Okay. Then her 3 friends help her, so now this would mean we're emptying that a lot quicker, right? Okay. So that gets us to our 3rd interval. Do that a little better. Okay. Now here we had them taking a break, so the water level would be right there, right? So maybe make it red so it shows up a little better. Maybe I should have done that the whole time. Okay. Then they clean the pool. The water level still stays the same because they're just cleaning it. Then it fills up, so it's going to be continuous again. And it says same rate as emptying the pool. So we kind of need to see if we can get our line to be about the same until we fill that pool up. Okay. Obviously my 6th interval went a little bit longer, which is fine. So there's just a basic graph. So, you know, right here we emptied with the hose, then 1 bucket, then 3 buckets, then a break because we were tired after removing them with the buckets, then we cleaned, and then we filled with the hose. Okay, so there's this. Now you could have kind of rearranged a few of these, but there's basically our graph, right? Now question 2 says create a story connecting the process from the graph we've created. So I'm going to answer question 2 down here, I think. So we started out and she emptied the hose with the hose until she got about halfway empty, and then the hose wouldn't work anymore. So then she started using a bucket to help empty it. And then her 3 friends came over, her 2 friends I should say, and the 3 of them with buckets did it. Then they were so tired they took a break, then finally cleaned the pool, and then filled it back up to get ready for the party. Essentially there's our story problem. Could we add number and time? Yeah, we could do that. Okay. Now, question 3 says, does your graph represent a function? Why or why not would all graphs created for this situation represent a function? Okay. So before we talk about that, I guess we're a few things to mention. When we were going down, in a graph we call that decreasing, right? So we'd want to say the water decreases. Continuously, then discretely. These parts were discrete. Then the water level stayed constant while we took a break and cleaned. Then we filled it up, and we had that same slope. Okay, and filling it up, we were talking about increasing the water. So those are some math terms that we could use for that. So now, question number 3, is it a function or not? Well, remember we've got 3 rules to be a function. The first is that we have 2 groups. Do we have 2 groups? The height of the water and time. Yep, 2 groups, check. The second is there a pattern? Well, our pattern, our slope was going down, then it went down slower, then probably quicker, filled back up. So, yeah, there's a pattern to it, going down and up. The third is that 1-to-1. Okay, that idea that for every one input, we only have one output. So think about it. At any time here, did we have the height of water being more than one height? Okay, according to our graph, no. Remember, with graphs, the way we can check is a vertical line test. You create a vertical line, run it across the graph, and see if it touches the graph in more than one place. So if we did that, if we took, a line and went across here, all of these points were only touching that vertical line once, which means yes, it's a function. Okay, and really, if we rearranged our graph, what's the only way we could make this not be a function? Would be if we somehow had a magic pool where we had the different heights. I suppose the only time that would work is if we were thinking about kind of a pool like this, where it had the shallow end and the deep end. So as you're filling it, you're emptying it, and the water's right here, yeah, this height's going to be different than this height up here. So that's really the only time that it wouldn't work, I guess, is if you were to think about it that way and think about the whole height of the pool. But if it's a pool like this, then it would always be a function. So always a function. This one wouldn't be a function. Okay? Alright, well there's our main idea here for this one, so there we go.